Hello everyone, today we'll be looking at the quick solutions to the chemistry section of All India AIATS Test Series JEE Advanced 2020 Test 1A Paper 2 Quote ENF. So let's start with the first section, students. This section contains 6 questions. Each question has 4 options, out of which one or more than one option may be correct. So let's start with question number 19. So for question number 19 it says, which of the following statements is or are correct? So option A, it says delta S for the reaction of carbon solid plus O2 giving us CO2 is almost 0. So if we talk about this reaction, students, the delta Ng for this reaction is equal to 0. So the delta S value will be approximately equal to 0 in this case. So the first statement is correct, students. If we talk about the second statement now, pressure exerted by CO2 over excess CaCO3 solid is equal to the Kp of the dissociation of CaCO3 as given. Okay. So if we talk about this reaction, students, in this reaction, the only gaseous species is CO2, while CaO and CaCO3 are both in the solid phase. So if you talk about the Kp of this reaction, students, that shall be equal to pressure of CO2. So the second statement is also correct, students. If you talk about the third statement now, a process can be simultaneously adiabatic as well as isothermal. This is a correct statement, students. We can have a adiabatic free expansion, or we can just have a free expansion in which there is expansion happening against vacuum. So that process is simultaneously adiabatic as well as isothermal. Okay. If we talk about the D statement now, for a process, the sum of two path function will always be a path function. This statement is incorrect, students. We know that from the first law of thermodynamics, Q plus W is equal to delta U. Q is a path function, W is also a path function, whereas delta U is a state function. So this is a state function, whereas both Q and W are path function. So the sum of two path functions may be a state function. Okay. So the D statement is incorrect, students. So for this question, we have to mark the correct answer as option A, option B and option C. Let us look at the next question now. Question number 20. For a solution formed by mixing liquids P and Q, the vapor pressure of P is plotted against the mole fraction of Q and it is shown in the figure. Okay. So we have to very carefully look at the axis, students. In the y-axis, the vapor pressure of P is plotted, while on the x-axis, the mole fraction of Q is plotted. Okay. So the examiner seems to be interested in the statements which are applicable for the system. Okay. So looking at option A, it says attractive intermolecular forces follow the order of PQ greater than PP and PQ greater than QQ. So if we look at the graph which is given to us, students, we can see that this graph shows a negative deviation from Raoult's law. So if the graph had been ideal, we could have gotten a straight line. Okay. But we can clearly see that the graph lies below this straight line plot. So it shows a negative deviation from Raoult's law. So if the deviation is negative, it means that the intermolecular forces between P and Q are stronger. Okay. So students, we can clearly see that the first statement is correct, students. If we talk about the second statement now, the pressure Z represents the vapor pressure of pure P. This is also correct, students. When the mole fraction of Q is 0, it means that the mole fraction of P will be equal to 1. So when the mole fraction of P is 1, the vapor pressure is given as Z. So this must mean that the vapor pressure of pure P is equal to Z. Okay. So the second statement is also correct, students. We can talk about the third statement now. The attractive intermolecular forces follow the order QQ greater than PP. So students, as we can see from the graph, there is no information given about Q. So since there is no information about Q, we cannot comment on the intermolecular forces of attraction of PP and QQ. Okay. So this is not a deduction from this graph. If we talk about option D now, the vapor pressure of pure Q is greater than pure P. Again, this cannot be deduced from the graph. There is no information given about Q alone. Okay. So students, for this question, we have to mark the correct answer as option A and option B. Let us look at the next question now. Question number 21. In a bimolecular reaction, the experimental steric factor is represented by the letter P. Select the correct statements out of the following. Okay. If P is more than 1, experimentally determined value of frequency factor is greater than that predicted by the Arrhenius equation. Okay. So students, if we talk about the frequency factor. So the frequency factor is given by the letter A in the Arrhenius equation. So we can have K is equal to A into e to the power minus EA by RT as per the Arrhenius equation. So this is the frequency factor. Okay. Now in the option, the examiner tells us that the experimentally determined steric factor. So we have the letter P. So we know that A can be related as P into Z, where Z is the total number of collisions per unit volume per unit time. And P is known as the steric factor. Okay. So students, if the experimentally determined value of the P is greater than 1, this must mean that the experimental value of the frequency factor will be greater as compared to that predicted by the Arrhenius equation, because the Arrhenius equation assumes that the probability factor is less than 1 or the steric factor is less than 1. So the first statement is correct, students. If we talk about the second statement now, if P is less than 1, experimentally determined value of frequency factor may be approximately equal to that predicted by the Arrhenius equation. So this is correct, students. Arrhenius equation assumes the steric factor or the value of P to be less than 1, and if the experimental value is also less than 1, then it might be possible that both of them have approximately the same value. Okay, so B statement is also correct, students. If we talk about statement C now, if P is more than 1, then the rate determined experimentally must be equal to that predicted by Arrhenius equation. This is not correct, students. If the value of P is more than 1, the experimental rate will be greater as compared to that predicted by the Arrhenius equation. Let us look at option D now. If P is less than 1, then the rate determined experimentally will be greater than that predicted by Arrhenius equation, as the activation energy is lower than that predicted by the Arrhenius equation. So student, this statement is not correct. The activation energy factor is not dealt with when we are talking about the steric factor P. Okay. So students, for question number 21, we have to mark the correct statements, the option A and option B. Let us look at question number 22 now, students. Consider a reaction taking place in a container in equilibrium with its surrounding. The effect of change of temperature on the equilibrium constant K is described by. So the examiner seems to be interested in the variation of K with the increment in temperature for an exothermic as well as an endothermic reaction. So students, if we have delta H as negative, which means that the reaction is exothermic. So for exothermic reaction, students, we know that as temperature increases, the value of K, it decreases. And if we talk about delta H being positive, that is endothermic reaction. So as temperature increases, the value of K also increases. Okay. So if you look at the options which are given to us, students, we can clearly see that option A is correct, which says that as temperature increases for an exothermic reaction, the K decreases. And if you look at option C and option D now, so out of option C and option D, we can clearly see that the option C is correct, which says that as the temperature increases for an endothermic reaction, the value of K increases. So for question number 22, we have to select the correct answer as option A and option C. Let us look at the next question now. Question number 23. For 1 mole of a real gas following the van der Waals equation at constant temperature T. So we have 1 mole of a real gas. It is at a constant temperature T. So we can write the van der Waals equation as P plus A by V square into V minus B equal to RT. So if we talk about the A option now, the plot of PV versus 1 by V is a straight line when the value of B is equal to or approximately equal to 0. So if you look at the first statement, students, when the value of B is approximately equal to 0, we have P plus A by V square into V equal to RT. So if we simplify this, we have PV equal to RT minus A by V. So students, this is a straight line. PV is the Y, 1 by V is the X, so minus A will be the slope. So this is indeed in the form of Y equal to mx plus C. So students, option A is correct. If you look at option B now, the plot of PV versus P is a straight line when value of A approaches 0 and B approaches 0. This is correct, students. When the value of both A and B will be approximately equal to 0, then in that case, the gas will behave ideally, and for an ideal gas, the plot of PV versus P is a straight line. If you look at option C now, the plot of PV versus P is a straight line when value of A is approximately equal to 0. We can have that case as well, students. If we talk about the C statement now, we have A approximately equal to 0. So this can be equated to P into V minus B equals RT. So on simplification, we have PV is equal to BP plus RT. So again, if we look at this form of the equation, we have Y, we have X. So this is also in the form of Y equal to mx plus C. So students, statement C is also correct. And if you look at option D now, the plot of PV versus P cannot be a straight line under any condition. So this is not correct, students. We had just seen 3 cases in which the plot of PV versus P comes out to be a straight line. So students, if we talk about the answers which we have to mark, so the answer to this question should be option A, option B and option C. Let us look at the next question now. Question number 24. Bombardment of a nucleus by alpha particle leads to its artificial disintegration via the 2 parts 1 and 2 to form P and Q respectively. Q further disintegrates to form P and T as shown below. So the series of reactions has been given to us. So the examiner seems to be interested in knowing about the particles R, S and T. So students, the concept of solving these sort of questions are very simple. We just have to apply charge balance and mass balance. So if we talk about the first reaction, we have XAZ plus alpha. So students, alpha is 4 and 2. The mass of alpha is 4 units, whereas the charge on alpha is 2. So this along path 2, it gives us Q, which is A plus 3 and Z plus 2. So if we talk about S, students, we have to apply charge conservation. So the total charge on the left hand side is equal to Z plus 2. So the charge on S has to be 0. If we talk about the mass, the total mass on the left hand side is A plus 4. So S has to have a mass of 1 unit. So S has a mass of 1 unit and has a charge of 0. So S is a neutron, students. Okay. Now it is further given to us that X, when bombarded with alpha particles along path 1, it gives us P, A plus 3 and Z plus 1 along with the liberation of R. So similarly, we can have charge balance and mass balance, students. If we balance the mass, we have a total mass of A plus 4. So the mass of R has to be 1. If we talk about the charge, the total charge is Z plus 2. So the charge on R has to be 1 again. So R has a mass of 1 unit and has a charge of 1 unit. So this has to be a proton, students. So R is a proton. And now if we talk about the last reaction in which Q disintegrates to form P and T. So Q A plus 3 Z plus 2 gives us P A plus 3. The charge on P is Z plus 1. So if we talk about the T, we can apply charge balance, mass balance against, students. So the mass is already balanced, so T is not supposed to have any mass. And if we talk about the charge, so there has to be a total of plus 1 charge on T. So if you look at the particle T now, students, it has a mass equal to 0, whereas the charge is plus 1, so it has to be positron. Okay. So if you look at the options which are given to us, students, we can clearly see that option A is not correct. R is not a neutron. R is but a proton. So D is correct, students. We can see that S is indeed a neutron. And if we talk about T, T is a positron as we had seen just now. So option C, option B and option D are correct. So for this question, students, we have to mark the correct answer as option B, C and D.